All right, so this is kind of the last chapter we have left for the semester. We do have Chapter 9 left. Chapter 9, I don't do a test over Chapter 9. It's just a 50-point take-home assignment that's already available on my webpage. And there's no homework to turn in. There's no homework you really have to do. That take-home assignment that's available for Chapter 9, you can just kind of watch the videos from Chapter 9, and as you're watching the videos, you'll be able to figure out the take-home assignment. So we just need to get through Chapter 8, and there aren't any word problems in Chapter 8, so it should be a pretty nice chapter. The section 8.1 is called Systems of Linear Equations. Each of the problems in section 8.1 will have at least two equations. You need two or more equations to be a system of equations. So this would be a system of equations. It's more than one equation. Equations have equal signs. And they're linear equations because the x's and the y's don't have exponents. If we had exponents for either the x or the y, then it wouldn't be a linear equation, a system of linear equations. So the first thing we need to be able to do is figure out what a solution to a system of linear equations look like. And let me real quickly show you graphically what a system of linear equation solutions look like. So I'm going to look for a few minutes here at problem number 1 and do something that's not required. This is like extra. I'm going to graphically, just to show you how these things can be solved graphically, solve the system 3x plus 2y equals 11 and 2x minus y equal to 5. Graphically, what we're finding is where the equations, the graphs of the equations intersect. So in order to solve this graphically, we need to rewrite each equation and solve it for y. So the top equation, 3x plus 2y equal to 11, I'm going to set this up to graphically solve by isolating the y, by first minusing 3x from both sides, and then dividing everything by 2. And on my calculator, I'm going to enter 11 minus 3x over 2 in my y1. And really specifically, I'm going to enter y1 equals, I'm going to do 11 minus 3x in a parentheses and then divided by 2. For the alternate equation, the 2x minus y equal to 5, the nicest way to solve it for y, because if I'm going to solve graphically and use my calculator to solve, my calculator needs an equation to be solved for y. I'm going to add y to both sides. That's going to give me 2x equals y plus 5. And then I'm going to minus 5 from both sides and get 2x minus 5 equals y. And on my calculator, I'm going to enter y2 equals 2x minus 5. What this is going to do, it's going to give me a graph of both equations. Rewriting the equations to make them graphable on my calculator won't change the graph. So the graph of these two equations and the graph of these two equations will be exactly the same graphs. And I'll show you visually what happens here. So if I graph the first equation in y1, 11 minus 3x divided by 2, and y equals 2x minus 5 in my second equation, what I'm finding when I solve this system of equations is where the two graphs intersect. And problem 1 says verify that the solution that's given is actually a solution to the system of equations. So visually it means verify that the graphs of the two lines intersect at the point 3, 1. Let me check that real quickly by going second in table, and I'm going to look at next to 3. If you look at 3 in the x column, you'll see for the first graph it has 1 in the y column, and for the second function it has 1 in the y column. So I'm pretty sure that that point is the point 3, 1. Another thing I could do is do this. And again, we don't have to do this. This is just to help your understanding. If I could go second and hit the trace key, go down to intersect, and then trace kind of close to that intersection point and just hit enter 3 times. So I did second, trace, went down to intersect, and I'm just going to trace close to the intersection, and I can be really careless and just get close to the intersection, hit enter 3 times, and it tells me those intersect at 3, 1. So a point is a solution to a system of equations if it's where the 2 lines intersect. So that's visually what we're doing in section 8.1. When we're solving a system of equations, we're finding the point where the graphs intersect. So all this is extra, has nothing to do with solving problems 1 through 6. So problems 1 through 6, there really isn't any algebra to do. We're just supposed to essentially check the solution. So we need to check in problem 1 that the point 3, 1 is a solution to the system of equations. And the system is 3x plus 2y equals 11 and 2x minus y equal to 5. What needs to be done to verify that the given values for x and y are the point is a solution, what needs to be done to finish up problem 1 is I need to go ahead and plug in 3 for x and 1 for y in the top equation, and I need to plug in 3 for x and 1 for y in the bottom equation. And the only way that this is in fact a solution to the system of equations is if both simplifications come out to a true statement. This statement here would give me 9 plus 2 equals 11, and it would give me 11 equal to 11. And the bottom one would give me 6 minus 1 equal to 5, which gives me 5 equal to 5. So I'm done what needs to be done. I've verified that 3, 1 is a solution to the system of equations. How did I verify it? I plugged it in, and it worked in both equations. For number 2, I could do exactly the same thing. I can plug in 4 for x and 2 for y into the top equation, and I can plug in 4 for x and 2 for y into the bottom equation. And when I do that, I have to get 2 true statements. In the top equation, I'd get 16 minus 6 equals to 10, and that would give me 10 equal to 10. In the bottom one, I'd get 8 plus 2 equal to 10, which would give me 10 equal to 10. So that's how you verify a system of a solution is a solution to the system of equations. You just plug that solution in for the letters in both equations, and it has to work in both equations. If it works in one equation but not the other, then it's not a solution to the system. So each of the problems between 1 and 6 give me an equation, and I'm just supposed to plug the values in for the letters and make sure I get true statements. This chapter 8 could feel different if you're my current semester students. I'm updating my videos this semester, and in previous semesters I didn't show both even and odd problems on the screen. So this might be new for you guys. For the rest of chapter 8, as you go through the videos, I'll mostly do the even problems, and the odd problem will be right there for you to look at. If you've been going through the new version of my videos, this is just old hack. So if I'm going to do problem 4, you should be able to do problem 3. So I'm going to verify that the point 5, 7 is a solution to the system of equations by plugging in 5 for x and 7 for y into both equations. So in my top equation, I'm going to go 4/5 times 5 minus 3/7 times 7, and that has to equal 1. And for my bottom equation, I'm going to go 2 times 5 plus 7, and that has to equal 17. If you're not comfortable working with the fractions, you certainly can use your calculator, but I know that these 5s and those 7s will cancel. When they cancel into 1s and makes it so I don't need the fraction anymore. And that's going to return into 4 minus 3 equals to 1, which gives me 1 equal to 1. So 5, 7 is a solution to the top equation. It also has to be a solution to the bottom equation to be a solution to the system. And I'll do this algebra that's implied by the numbers in the bottom one. And that's all I'm going to show. I've verified that 5, 7 is a solution by plugging it in separately into the top and the bottom of the equation and getting 2 true statements. You should do the same for number 3. Graphically, if you solve these for y and graph them, the lines would intersect at the point 5, 7. The next problem is a system with technically not, I guess they're technically linear, but these are 3-dimensional. They'd actually graph into like a sheet of paper. They graph into something called planes. And when we have 3 equations and 3 unknowns, the point that we're going to be given to check has to have 3 values, one that corresponds to x, the second to y, and one to z. When you go to do number 3 to see if this point is a solution to the system of equations, the x is going to be 3, the y is going to be 2, the z is going to be 1. Graphing in 3 dimensions is something my calculator can't do, and graphing in 3 dimensions is something that's kind of beyond the scope of the class. But essentially, each one of these is a sheet of paper that would graph, and you're finding where the 3 sheets of paper simultaneously intersect. To verify that something's a solution, it's super easy. So to verify for problem 6, I'm going to go to the top equation, plug in 4 for x, 2 for x, 4 for y, and 1 for z, and that should equal the right side of 2. In the middle equation, I'm going to plug in 2 for x, 4 for y, and 1 for z, and make sure that both sides equal 3. And in the bottom equation, I'm going to plug in 2 for x, 4 for y, and 1 for z, and make sure I get 7. So top one, I get 4 minus 4 plus 2. Those 4's cancel, and so that would simplify to be 2 equal to 2. That's good. So 2, 4, 1 is a solution to the top equation. But just because it's a solution to the top equation doesn't mean it has to be a solution to the middle or the bottom equation. So I need to check that independently. For the middle check, I'm going to get 6 minus 4 plus 1. 6 minus 4 is 2 plus 1 is 3. So that's also going to give me a different true statement, but a true statement. And the last one, I get 7 equal to 7. So I've verified that my solutions are correct. And that's going to probably be something that's really a good idea to do. The rest of the problems in this section, we're going to use algebra strategies to generate a solution, and then we should probably check it. And there's 2 big algebra strategies to use that can be used to solve systems of equations. And the first method that we're going to learn is called the substitution method. So problems 7 through 20, ultimately, each of the problems between 7 and 20, I'm going to solve using the substitution method. There's a lot more written after the portion of the problem that tells me what to do. Sorry, I needed to get some paper and I didn't have it handy. So there's a lot of words written after the part that I boxed. What I'm going to do is I'm going to solve each system using the substitution method, but then there's some other junk down here. And then after the keywords, it says, if the system has no solution, say that it is inconsistent. So graphically, what can happen for these systems of equations, at least in 2 dimensions, at least I can show you that graphically, when you're solving a system of 2 linear equations, you could get one solution. And the graph that I did earlier was exactly an example of that. You could have the lines going in directions so that they just cross in one place. So this would be an example of the graphical interpretation of a system of equations that has one solution. That's the most common thing that can happen when you're solving a system of equations. You'll just get one solution. It also could happen that when you're solving a system of equations that there's no solution. And graphically how that can happen is we're finding where 2 lines intersect. If I graph the first equation followed by the graph of the second equation, if the graphs don't intersect, then that system of equations would have no solution. And for an answer, we're going to say that's an inconsistent system of equations. Algebraically, because we're going to be solving these using algebra, algebraically, I can tell that there's no solution when all of the letters cancel and a false statement is left. Real common, the algebra, like for this, might produce something like, I don't know, something like 0 equal to 7 or something silly. The letters will drop out and you'll be getting a statement that's nonsense. And when that happens in the algebra, then the lines, if we were to graph them, they'd be parallel lines, and that problem will have no solution. That's kind of good. No solution / we can say it's the answer that it's an inconsistent system of equations. This is considered a consistent system of equations that has one solution. The other thing that could happen when I'm solving a system of equations pictorially is that the system can have infinitely many solutions. That's kind of the bugger here. So the third case, so you could have one solution. That's if the 2 lines intersect in one unique points. You could have no solutions or an inconsistent system of equations if the lines would be parallel, or if the letters drop out and you're left with a nonsense statement. Graphically, there are infinitely many solutions if you went to graph the first equation and then you followed it up with a graph of the second equation, and the graphs were right on top of each other. If they graph to be the same line, then every point on the line is on both lines, and there's infinitely many points on the line, so there's infinitely many solutions. Algebraically, I can tell that there are infinitely many solutions when all of the letters drop out and you are left with a true statement. as opposed to a false statement. For example, the algebra might produce, something like 3 equal to 3. All the letters drop out, but on either side of the equal sign you have the same number, whereas it's inconsistent when the letters drop out and you're left with numbers that don't equal each other on either side of the equal sign. Most of the problems that we're going to do between 7 and 20 are going to have one solution, and if the letters don't drop out, we're going to have one solution. If the letters drop out in the middle of the algebra, then it's either going to be inconsistent with no solution, or it's going to be infinitely many solutions. And then when there's infinitely many solutions, we have to write the answers in a fancy way. And I'll talk about that when it's probably more appropriate. So that's just a bunch of theory behind just what we're doing in this section. It hasn't really mentioned about how to solve a problem. So to solve the problems using substitution method, it requires a few steps. So the first step is to pick any one of the equations, and pick any one of the letters and solve the equation you picked for that letter. And then this step can be skipped if one of the equations is already solved for a letter. So for problem 8, what I'm going to do is I'm going to look at my equations. If one of the equations is solved for a letter, then I can skip this step. So in problem 8, because my top equation is solved for x, I can skip this step. In problem 7, because your top equation is solved for y, you can skip this step. When we get on to the next group of problems, problem 9 and 10, there is not an equation in number 9 that's solved for x. There's not an equation for number 9 that's solved for y. Similarly, in number 10, there's not an equation solved for x, nor is there an equation solved for y. So I'm going to have to do this step. So I'll talk in more detail about what to do on this step once I get to the next problems. But in this time, we can skip this step. So there might be a little hiccup in the video. I did problem 8 and I made a mistake and I just cut it out, and I'm going to put the correct version of problem 8 in the video now. So I'm skipping step 1, moving on to step 2. Step 2 says substitute into the other equation and solve for one of the letters. So what I'm going to do, because the top equation is solved for x, I'm going to substitute for x in the bottom equation 2y minus 3. The first step of my algebra is going to be this step to substitute into the other equation and solve for one of the letters. So I'm going to take this equation and make it 4 times 2y minus 3 plus y equals to 5 for my first step of problem 8. When you go to do your problem 7, because your top equation says y equals 2x minus 4, you're going to change in the second equation the y to 2x minus 4. And your first step is going to say negative 2x plus 3 times 2x minus 4 equals 0. And you're going to finish up this step by solving this equation for one of the letters. You're going to solve that equation for x. I'm going to solve this equation for y because I have a different letter than you. So I'm going to clear the parentheses here. I'm going to go 4 times 2y and get 8y. 4 times minus 3 and get minus 12. And this is really plus 1y equals to 5, just to make sure that when I combine these I do well. And now I'm on the left-hand side, I'm going to add the 8y and the implied 1y. It's going to give me 9y minus 12 equals to 5. This is a really unfortunate beginning problem because it has a fraction answer. And that's probably why I made a mistake the first time, because as a fraction, it's easy to make mistakes with fractions. So I'm solving this. I'm down to the point where I am ready to divide, and I get this horrible fraction of y equal to 17 over 9. I'd like to hope your problem doesn't have a fraction answer. So step 1 I didn't have to do because I had an equation solved for a letter. Step 2 I'm done with. I substitute into the other equation and I solve for one of the letters. Now I need to do step 3, solve for the other letter. The other letter for me is going to be the x. So I'm going to do my solving for x, and I can do that going down linearly here. So now I'm going to solve for x. This is my step 3. And the best way for me to solve for x is to use this top equation. So I'm going to use the equation x equals 2y minus 3, and I'm going to plug in 17 over 9 for y. I certainly don't want to do this by hand, so I'm going to pull my calculator out, clear all my mistakes out of there, and go 2 times 17 divided by 9 minus 3, get a decimal, and then math and enter twice to get a fraction. So I entered the problem 2 times 17 divided by 9 minus 3, enter, and then math, enter, enter. This gives me x equals 7 over 9. So my answer to problem 8, the solution to the systems is the point x equals 7/9, y equals 17 over 9. I'm done, but I certainly can check, so I might as well check because I don't like the idea that I had fraction answers. So I'm going to sneak the checking right here. This is optional. Checking. On the last video that I just cut out, my checking didn't work, so it was good that I checked because I would have had a mistake here forever. So what I'm going to do is plug in 7/9 for x into the top equation, 17/9 for y into the top equation, and make sure both sides simplify to be the same side. That really just involves simplifying the right side, and I'll do that on my calculator. So on my calculator for the right side, I'm going to go 2 times parentheses 17 divided by 9 minus 3, and then math, enter, enter, and I get 7/9. So in the top equation, when I plug the answer in for x and the answer in for y, both sides simplify to be the same. Now I'll go down to the bottom equation, 4x plus y equal to 5, and in for x, I'm going to plug 7/9. In for y, I'm going to plug 17/9. And I'm only going to simplify the left side because the right side's already 5. So now I'm going to go 4 times 7 divided by 9 plus 17 divided by 9, and I better get 5, and I do. So I know 100% for certain my answer for number 8 is correct. This is completely optional, the checking, but it's not a bad idea to do. So your problem 7 should work real similarly. I'd like to think you don't get a fraction, and you're not going to get a fraction. Your answers are going to be much nicer than my answers. All right, so moving on to problems 9 and 10. And this is the part where if you're going to get confused, this is where the confusion's going to start. Because I look at my first step, and there's lots of flexibility. I need to pick any one of the equations and any one of the letters and solve the equation for that letter, which means I could pick the top or the bottom equation And once I pick that equation, I can solve for x or I can solve for y. So for step 1, I need to pick an equation, and you can pick the top or the bottom one. And you need to pick a letter to solve for. You could pick x or y. There's no right or wrong thing to do, but there's things that are easier to do. So my step 1 is I'm going to pick the bottom equation, and solve for y. It wouldn't have been wrong to pick the top equation and solve for x, but solving the top equation for x would introduce a fraction. I can solve the bottom equation for y in one step, and it's not going to introduce a fraction, and I'd rather avoid fractions. That's probably what you should do when you do number 9 for your first step. Although you could pick the top equation and solve it for x, or you could pick the bottom equation and solve it for x. The easiest thing to do, the way these problems are kind of designed, is to take the bottom equation and solve it for y. So that's my step 1. Done with it. I had to do it because there wasn't an equation solved for a letter. Now I'm going to substitute it into the other equation. So I pick the bottom equation. I'm going to substitute it into the other, which is the top equation. So for my step 2, into the top equation, I'm going to replace the y in that top equation with negative 2x plus 5. So I'm going to rewrite the top equation as 4x minus 3 times negative 2x plus 5 equal to 5. That's just taking that right there and putting it inside of parentheses with a negative 2x plus 5 and leaving everything else intact. Now I'm going to clear the parentheses. I'm going to go minus 3 times minus 2x and get positive 6x, minus 3 times positive 5 and get minus 15. Now I'm going to combine the 4x and 6x and get 10x. And then I'm going to add 15 to both sides. Lastly, I just need to divide by 10. I'll be done with step 2, and I'll have a step 3 left. So this is going to give me x equal to 2. Step 3, solve for the other letter. I can use any equation. I could use that equation, or that equation to solve for the other letter. The other letter is y. The easiest equation to use to solve for y is this one. But if you use that one or that one and plugged in 2 for x and did the algebra to solve for y, you'll get exactly the same answer with just a little more work. So my step 3, there's flexibility here. There isn't a wrong equation to pick, but I'm going to pick the equation y equals minus 2x plus 5 and change the x to 2. So I'm going to go y equals negative 2 times 2 plus 5. That's going to give me y equals negative 4 plus 5, which is y equal to negative 1. I'm done other than if I want to check, and I don't really feel the urge to check every problem, so I'm just going to say my answer to problem 10 is going to be these two lines are going to intersect at the point x equal 2, y equal to negative 1. Actually, it should be y equal to positive 1 because negative 4 plus 5 is positive 1. Checking is always smart to do because if you check, you can know that your answer is right. If you don't check, you could write a wrong answer down that you don't need to write down. But again, it takes so long on these videos just to do the problems without checking. I won't check every problem. I'll hope that I don't make an error. All right, so give number 9 a go. And now we're on to some monster problems with fractions. 11 and 12 have fractions. 13 and 14 have fractions. So I need to pick an equation and solve it for a letter. I'm definitely not going to pick the top equation because it's disaster. So I need to pick an equation and pick a letter to solve for. I'd like to find letters that don't have numbers in front of them. top equations, I'm not going to pick any letter that has a fraction in front of them. I won't pick the top equation. I'm going to pick the bottom equation because at least there's not fractions. I need to pick a letter to solve for. The x has a 2 in front of it. The y has a 1 in front of it. I'm going to solve for the y because it's easier. That's what you should do for number 11. So my step 1, I'm going to take this 2x minus y equals to 8 and solve it for y. That's going to take 2 steps. First, I'm going to add y to both sides. That's going to give me 2x equals y plus 8. And then I'm going to minus 8 from both sides. That's going to give me 2x minus 8 equals to y. Now, it depends if you want to fight fractions or not. You can go straight into your step 2. I'm going to substitute into the top equation and solve for x. Many poor students will go directly from my first step to my second step without doing something that's legal to do. What is legal to do when you're solving a system of equations is if there's an equation that has a fraction, you can clear the fractions by multiplying everything by the least common denominator. And there's lots of ways to do that. In college algebra, we should do a fairly sophisticated way. So what I'm going to do, I'm not going to substitute it into the top equation. I'm going to substitute it into the better version of the top equation. That fraction version would be disaster. If I had to go make y equal 2x, I'd have to go 2/5 x plus 1/2 times 2x minus 8 equal to 4. If you're comfortable doing that algebra, substitute it straight into the top equation. If you're not comfortable doing that algebra, substitute it in the better version of the top equation. I need to create the better version of the top equation. So I'm going to create a better version of the top equation by multiplying to clear out the fractions. What I'm going to do is I'm going to go 10 times, 10 times, and 10 times. I'm going to go 10 times 2/5 x plus 10 times 1/2 y equals 10 times 3. So because 10 is the least common denominator between 5 and 2, multiplying by 10 is going to clear the fractions. The first canceling, the 10 was going to cancel with the 5 and become a 2. I'm going to be left with 2 times x, which is 4x. Second canceling, the 10 is going to cancel the 2. The 2 is going to turn into a 1. The 10 is going to turn into a 5. I'm going to be left with plus 5 times 1 times y, which is plus 5y. That's hardly readable. So far I have 4x plus 5y. And to the right of the equal sign, 10 times 3 is 30. So the better version of the top equation is 4x plus 5y equal to 30. So what I'm going to do now is I'm going to use this 4x plus 5y equal 30, which is the better version of the top equation, and I'm going to substitute y equal to 2x minus 8. So for the y in that equation, I'm going to change it to a 2x minus 8, and this is going to give me 4x plus 5 times 2x minus 8 equal to 30. This is going to give me 4x plus 10x minus 40 equals to 30. This is going to give me 14x minus 40 equals to 30. I'm going to add 40 to both sides, and that takes me to 14x equals 70. Now I'm going to divide both sides by 14. going to use my calculator because I think that comes out nice. So I'm going to go 70 divided by 14, and I get 5. That's really nice. So this is going to give me x equal to 5. Done with step 2, on to step 3, solve for the other letter. The best equation to use to solve for the other letter is that, but you can use any equation. So step 3, I'm going to solve for y. I'm going to use the equation y equals 2x minus 8, and I'm going to plug in 5 for x. So I'm going to go y equals 2 times 5 minus 8. That'll give me y equals 10 minus 8. That will give me y equal to 2. My answer is going to be the point x equal to 5, y equal to 2. Because I started with such a horrible equation, maybe I should take the time to check. Now I'm going to check into the dirty equations. So I'm going to check, and it's optional. The first equation started off as 2/5 x plus 1/2 y equal to 3. To check, it should be 2/5 times 5 plus 1/2 times 2 equals to 3. Let me do that on my calculator. So on my calculator, clear 2 divided by 5 times 5 plus 1 divided by 2 times 2, and that better equal to 3, which it does. That's half the checking. The other half of the checking is going into 2x minus y equal to 8. And again, I'm going to plug in 5 for x and 2 for y. This is going to give me 10 minus 2 equal to 8. And that's 8 equal to 8. So 5, 2 is in fact the perfect solution. So you should do problem 11 the same way, meaning probably pick the bottom equation, solve it for y, and then substitute into a better version of the top equation by multiplying everything in the top equation by 6. So you're going to go times 6 times 6 times 6 and get an equation that's better to substitute in because it doesn't have the fractions. So our 13 and 14 should work similar. Step 1, pick one of the equations and pick a letter. I'm not going to pick the top equation because I don't want to deal with those fractions. I'm going to pick the bottom equation, and it's going to be super easy to solve for x. So for my step 1, I'm going to pick the bottom equation and solve for x. So that starts off with x minus y equals to 4. I'm just going to add y to both sides and get x equal to y plus 4. Step 2, I'm going to substitute into a nicer version of the top equation. Because that top equation I don't want to deal with. How do I get a nicer version of that top equation? Simple. I just multiply by the least common denominator to clear the fractions. Numbers might get a little out of control big, but it's okay. The least common denominator between 7 and 3 is 21. So I'm going to multiply by 21, 21, and 21. First multiplying, the 21 and the 7 will cancel. I'll be left with 3 times 4x, which is 12x. Second one, the 3 and the 21 cancel. I'm left with 7 times 1y, which is plus 7y. To the right of the equal sign, 21 times 5, I think is 105, and it is. So the nicer version of the top equation that I'm going to use is 12x plus 7y equals 105. And now I'm going to change my x to y plus 4. So I'm going to go 12 times y plus 4 plus 7y equals 105. Now I'm going to clear the parentheses. I go 12 times y is 12y, 12 times 4 is 48, plus 7y equals 105. I'm going to do two things in once because we need to start picking up some speed. So I'm going to minus 48 from both sides, and I'm going to combine the 12y and the 7y. And that on the left side, when I add the 12y and the 7y, is going to leave me with a 19y. And on the right side, I don't know how to do 105 minus 48, but it hardly matters. That's 57. And now I'm going to divide both sides by 19. And go 57 divided by 19 and get 3. Done with the second step. On to the third step. Solve for the other letter. That's solving for x. This is the nicest equation to use, but you don't have to use that one, but you'd be smart to use it. So I'm going to go x equals 3 plus 4. That's going to give me x equal to 7. And for an answer to problem 14, I'm going to say it's x equal to 7, y equal to 3. I certainly could check it, but I'll save a second and not check it. So this work should be real similar to the work you're going to do for problem 13. You should probably pick the bottom equation, solve it for x, substitute into a nicer version of the top equation. To get the nicer version of the top equation, you should multiply everything by 15. And that will give you a nicer version, and just kind of finish up the step 2 and step 3 just like I did. When I glance at problem 16 and I glance at problem 15, the two equations are, in some sense, multiples of each other. 3 times 5 is 15. The coefficient of this 1 times 5 is 5. When the left sides are multiples of each other like that, you have to worry about there being no solutions or infinitely many solutions. So step 1 should probably be similar to your step 1. I'm going to pick the top equation and solve for x. That's the easiest thing to do because there isn't a number in front of the x. Now I'm going to add 3y to both sides and get x equals 3y plus 7. Step 2, I'm going to substitute into the other equation and solve. This is where the first time it's going to happen that my algebra, the letters are going to drop out. So in the other equation, what I'm going to substitute is I'm going to take 3y plus 7 and I'm going to substitute it in for that x right there. So I'm going to go 5 times 3y plus 7 minus 15y equals to 9. This is going to give me 15y plus 35 minus 15y equals to 9. On the left-hand side, the 15y's cancel. And if I didn't subtract the 35, I'd get 35 equal to 9. If I subtracted the 35, I'd get 0 equal to minus 26. And this is a no solution inconsistent. If I were to graph these would be parallel lines. Algebraically, I can tell there's no solution when all of the letters cancel out and a false statement is left. What happened algebraically here, all of the letters canceled out on step 2, and I was left with a false statement. There's nothing more, there's no more algebra I can do. I can go straight to an answer, and the instructions say to write the word inconsistent for an answer. I'd probably never write that. I'd probably just say there's no solution, because graphically these lines wouldn't intersect. They'd be parallel lines. Take me another 3 or 4 minutes to graph them and show you. I'll skip that. If you want to see them graphed, shoot me an email or come visit me. I'll show you how to get these set up so you can see that they don't intersect. Your problem 15, I imagine, is also going to be inconsistent, but I don't know that for a fact. Problem 18, I need to pick an equation and solve it for a letter. And the bad thing about this method is sometimes you can't avoid fractions. Let me do your problem 17 just because we can't avoid a fraction, and maybe that might be much to handle. So I'm going to do 17 and not do 18. I could pick the top equation and solve it for x or y. I could pick the bottom equation and solve it for x or y. There isn't a good thing to do, but I think picking the bottom equation and solving it, top equation and solve it for y is good. Let me try that. So I'm going to pick, for problem 17, the top equation and solve for y. I think we can avoid fractions this way. Any other equation and any other letter, I think you're going to get a fraction. But let me try that. I picked that equation very carefully because I think I can avoid fractions. On my problem 18, there was going to be no way to avoid fractions. So I minus 4x from both sides. That's going to give me 2y equals to minus 4x plus 6. And now I'm going to divide by 2, divide by 2, divide by 2. That's going to give me y equals negative 2x plus 3. Done with the first step. So that's my step 1 for number 17. On to step 2. I'm going to substitute and solve. And I have to substitute it into the other equation. So I'm going to take this y equals negative 2x plus 3 and substitute it into the second equation because that's the equation I haven't used. So I'm going to change that y to negative 2x plus 3 for my step 2. I'm going to go 12x plus 6 times negative 2x plus 3 equals 15. That's going to give me 12x minus 12x plus 18 equals to 15, because when you clear this parentheses, you go 6 times minus 2x and 6 times 3. On the left side, the 12x's cancel, and this is the best thing. When the letters cancel and you're left with a false statement, there's inconsistent and there's no solution. So you can write, for this answer, I'm done with my algebra. And when I go to write, I can write inconsistent if this is, what I'm drawn to. Quite honestly, I don't generally write that. Or you can say there's no solution because these lines don't intersect anywhere. I don't often write test questions that have no solutions, but very infrequently it does happen. The next problem is going to have infinitely many solutions, and I can't ever remember writing a test question that has infinitely many solutions. So this isn't the most important thing in the world, but I'll do it for you. The next problem that we're going to do, 19 and 20, what's going to happen in the algebra is the letter's going to drop out and we're going to be left with a true statement. When that's the case, if you graph the lines would graph right on top of each other and there'd be infinitely many solutions. When that's the case, when there's infinitely many solutions, we have to write our answer in a very elegant form using set builder notation. Quite honestly, let me get into the problem and I'll tell you how I'd accept an answer in the most elegant way to write an answer. These infinitely many solution problems, the only time you'd see them again is if you took linear algebra math 342, so they're not that important, but they come up here, so let me do that. Really? Let me change my problem. Let me change my problem 20. Otherwise, I'm going to get an ugly fraction that I don't want to get. So let me change mine to 6x plus 2y equals 4 and 12x plus 4y equals to 8. So I'm going to change that whole problem, because problem 20, I would have horrible fractions to work with, and you don't want to watch me do fractions. So both for problem 19 that you're going to do and problem 20 I'm going to do, we can pick the top equation for my step 1 and solve for y. So I'm going to get 6x plus 2y equal to 4. I'm going to minus 6x from both sides. That's going to give me 2y equals minus 6x plus 4. And then divide by 2, divide by 2, divide by 2. And I'll get y equals negative 3x plus 2. Step 2. Substitute and solve. I have to substitute it into the equation I haven't used. So I'm going to take negative 3x plus 2, shove it in for y into the equation I haven't used, which is the top equation, but I'm doing this top equation. I'm going to substitute it in there. You're going to substitute it there. So I'm going to go 12x plus 4 times negative 3x plus 2 equals to 8. This is going to give me 12x, and then I'm going to go 4 times negative 3x is minus 12x. 4 times 2 is 8 equals to 8. The 12x's cancel. I'm left with 8 equal to 8. And when that happens, when all the letters drop out and you're left with a true statement, there's infinitely many solutions. Usually in my college algebra class, I just say there's infinitely many solutions and stop. So it would be completely okay if you just said there were infinitely many solutions on your homework problem for number 19. There's a better thing to do, and the better thing to do is to write the answer in the form that's hinted at the instructions. It says, if the system has infinitely many solutions, write your answer in this form. And this, to somebody that's taking Math 342, or at least the teacher of Math 342, would tell you how to generate infinitely many solutions. If you give me a value for x, I can give you a y, such that that point is the solution to both equations. Way, I think, beyond what we need to do. So I'm going to go ahead and just scribble this in here really quickly, but you're not responsible for it. But the proper way to write the solution when there's infinitely many solutions and if I even did more and explained, I think about why this is a nice way to write the solution, I think I'd just be teaching to myself. If you're interested in understanding why this solution is so elegant, then come visit me and I can show you its beauty. So the proper way to write a solution, because there are infinitely many solutions, is to use the quote-unquote, I don't know if we call it the shell, or the template, I guess, that's provided. Then change it to fit the problem. The shell that's provided is this shell right here. The solution to this problem is supposed to be the set of points in the form x, y, such that y is one of the equations and x is any real number. So this is the shell that's provided when the lines would graph to be the same line. I'm just going to change the shell to fit the problem. And how do I change the shell to fit the problem? I change just this part of the template to be fit with the problem, and I have that right there. I can replace the y equals mx plus b with y equals negative 3x plus 2 because that's what I got when I solved an equation for y. So the best answer for this problem, that if I were to graph these lines, would be coinciding lines, would be the set of xy such that y equals negative 3x plus 2, where x is any real number. You could actually say if y is any real number, but it's better to say x is any real number. In my solutions manual, I have a y here. It isn't wrong, but it isn't the best answer. So give 19 a go, and if you just want to write there's infinitely many solutions when you get done with 19, that's completely fine. This has to be a good stopping point because we're going to get into the next method, which is the elimination method. And then that will probably drag into a part 2, and there'll probably be a part 3 even for this section. So let me stop here and just get real good with the substitution method before you move on to the second part of this video for the elimination method. You might even want to take a good break between the two portions of the video.